Okay, let's try to do some more problems from what chapter are we in? Chapter 8. A force of 50 newtons is applied at the end of a wrench handle that is 24 centimeters long. The force is applied in a direction perpendicular to the handle as in the diagram. I redrew the diagram. That's a wrench, that's its lever arm length, and that's the force. What is the torque applied to the nut by the wrench? Okay, here's our nut. Here's our nut right there. Okay. We're going to turn him. What is this torque? So our lever arm is perpendicular to the force. So this length is the lever arm because this is perpendicular to the force that's being applied. It's like if I could redraw I should have drew the distance going like this, and that is 90 degrees from the force that's applied. So that's our lever arm. It's not if the force is not perpendicular, then the lever arm is a little different. But it's not that way in this problem, so I'm just going to continue with what we got. Okay, so our lever arm, how does your book denote that? So he uses an L. Okay, so L, lever arm, is equal to 24 centimeters. The force is 50 newtons. We're looking for the torque. Okay, so torque is equal to the force times the lowercase l lever arm. So in this case, you're just going to take your 50 newtons times your your lever arm. Now, we want torque to be a Newton meter. We don't want centimeters. So anytime you have a problem and you have centimeters, you might want to just, right up front, convert it. So I'm going to convert 24 centimeters to meters. It's a centimeter. For every 100 centimeters, we have 1 meter. So we have, let me mark this out, 0.24 meters. Okay, so now we can plug in and solve for the torque. Torque will equal the 50 newtons times the lever arm of 0.24 meters. And that will give us a unit of Newton times meter. So whatever answer you get here for taking 0.24 times 50, make sure the unit you have on that is Newton meter. Okay, so that's all of A. Let's focus on B now. What would the torque be if the force were applied halfway up the handle instead of at the end? So for B, let me see, I'm going to use purple. B, we're saying, okay, what if we put the 50 newtons there? Okay, do you think that's going to change the torque? Well, yeah, if we look at the equation, we're reducing our lever arm. We're changing the lever arm now. It's no longer 24 centimeters. It's half of that. So our lever arm is 12 centimeters, which is actually 0.12 meters. Our force is still 50 newtons, and the torque is what we're looking for. This unit should be Newton meter. Now, just by, let me plug in the numbers here, looking at it, without even plugging in or plugging into the calculator, you should see that the torque, whenever you put the force closer to your rotation, it's going to reduce the torque. Your force is the same, but the torque's getting reduced. That's why whenever you try loosening your lug nuts on your car or anything like that, you might get a cheater pipe. So you're working there on your car, got a wrench here, and you're like, just no matter what force I put here, it's not turning it. Well, you go get a bar and you put it on the end of that. Hey, you're increasing your lever arm. You can apply the same force, and you're going to get a lot more torque, and you're going to make that nut move. Okay, so that's I'll let you plug in the numbers there into your calculators. Just make sure your answers are